Alright, here we go. We're calculating the area of the kite. And what I really wanted you to do on this one is to utilize the graph and the information that it gives you. And so what I like is to split it up just two little triangles like this. Because that way they're both identical. And if we rotate it like this, you can see that this is the height, which in this case is 3. And this is the base, which in this case is equal to 12. So the area of one triangle is 1/2 of the base times the height. But then I have two of them. So real quick, I can figure out what the area is of the whole thing. Now the perimeter of the kite, I need to break it up into right triangles. So you see you have a right triangle here. You have a 3 here and a 4 here. Use Pythagorean theorem. You do need to make sure that the two legs are the ones that you're adding together to equal the hypotenuse squared. So we end up getting that 9 plus 16, or 25, is c squared. Now that's not c. C is the square root of that, so that's 5. Now I don't need to do this one over here because I do know that those two triangles are congruent to each other. So that will be equal to the same exact amount. But I do want to use this triangle right here. I have 3 squared plus 1, 2, 3, 4, 5, 6, 7, 8 squared is equal to c squared. So I have 64 plus 9 is 73. So when I square those, I get approximately 8 point, where's the square root? 73 square root of it is 8.54. This is also 8.54. So I can go ahead and add all 4 of those guys up together, and I get what, 16, 26, 27.08, is that right? Times 2 plus 10 is, technically it's 09, because if you look at that guy right there, it does say 088, so when I stop writing I do always want to look at one more number to check it out, and that would be the perimeter of the kite. Now for C, what we did is we said, okay, what if they weren't numbers? What if they were letters? And if I split it up in the exact same way I split it up last time, this would be, say, M, or one of the diagonals, and this guy here is half of that diagonal. This is my line of symmetry, so these are both equal to each other, so that's equal to 1/2 of n. So to find the area of one triangle, I have half of the height times the base. That gives me one triangle, but I actually have 2 of them. So when I do that magical little math there, I do get that there is a formula that gives us that it's 1/2 of one diagonal times the other. There you go.